Good afternoon, Dr. Thigle and all of you. So we'll start in
Good
5 minutes
afternoon, sir.
probably.
Good afternoon.
Good.
Welcome back, sir. Uh,
Thank you.
okay. Just I will take 1 minute, sir. Then I will hand over
Yeah,
the
sure.
mic.
Sure.
Dear participants, tomorrow schedule will be like we are going to start the session at 2 to 4. There will be a test. Basically, one test will be covering DevOps part, and one test will be there covering blockchain part. So we are giving actually 45 minutes time is sufficient for one test, but we are giving 2 hours you for the test. So 2 to 4 there will be a test, online test, MCQ questions will be there. The link for the quiz will be shared you on WhatsApp group and even on this chat also. And then second session we are starting around 4:30. So 4:30 to 5:30 there will be a session by Ashok Ranade sir and Atul Marathe sir discussing various opportunities. And from 5:30 onwards we will have a valedictory session. Certification link will be shared only during this valedictory session. So attendance for this valedictory session will be compulsory. So we'll update you a detailed schedule very soon. Thank you. Sir, over to you, Prakash sir. Thank you. Over to you, sir.
Yeah. Thank you, Dr. Thigle. So good afternoon, everyone. So we are in day 5. So we learned about so what is DevOps, then what is Agile. Then next day we talked about continuous integration. Then we talked about continuous deployment and continuous release management. So that we covered, and now we are going to talk on. So we also talked on operation management. So that is infrastructure as code and how servers and infrastructure is managed in DevOps way. Now today's session will be on continuous testing. Okay, sharing my screen. Is my screen visible?
Yes, sir, visible.
Okay, great. So when continuous integration is done, like your source code is built successfully and you have captured whatever defects are there in unit testing and you have fixed that. So your code is as good as it can go for further QA, that is quality assurance. So that it is more rigorously tested, like your functional testing or performance testing rehabs. So and also any sort of security testing. So that those types of testing will be extensively performed in automated way. And so what are the different things we need to consider during continuous testing, that we'll see. So test automation and continuous testing. So primary purpose of testing is to validate the system against the expectations. So when business owner has some vision, has some goal from the software being developed, then whether that goal is getting fulfilled. So when requirements are defined based on that goal, so whether each requirement is developed, is built, and is available for end user as it is expected, that needs to be validated, and that is done during testing. So it can be done in automated way or manual way. So we have seen most of the testing happens in manual way, but always there is focus to increase automation to the maximum extent and bring test automation. So that was means during waterfall also efforts were put to bring test automation. Uh, but it was like so when each phase is getting completed, then test automation is happening or manual test is happening. So challenges with manual testing that you are not sure that all scenarios are tested properly or depends on person's knowledge and very much being manual effort. So you are not sure it's being tested correctly and thoroughly and extensively. So test automation also you need to put efforts. So a lot of efforts are required to automate so that to write automated test script, write the test scripts. Individual testers, they need to learn the testing tools and each tool means any tool will not be like comprehensive to cover all sort of technologies or scenarios, and then you may have to bring one or two tools or more tools, and then having knowledge of each tool for the team is could be a challenge. So automation is also not that easy, and also automation of all sort of test scenarios is also not possible because of again technology or tool is not supporting or there are challenges with test data also because there is huge data in production, but similar data cannot be available during testing phase. So such challenges, how that can be coped up and bring efficiency in test automation. Those were challenges, but test automation is more to reduce manual efforts, improve person dependency, and bring efficiency in the testing. And it's performed at the end of each phase. So as this diagram shows, so you write the code, then unit tests are performed, then integration build and deploy on staging, then you write automation integration test scripts and functional test, and that testing happens. Then you deploy on UAT, user acceptance test environment, and then UAT happens. So it's like phase-wise approach. Though it's automation, though it's bringing some efficiency, but it's done in phased manner, one after another, in the previous era. So that's why it's not that efficient and it's time consuming, and you are catching defects at later stage. So if you are catching defect here after code is built and deployed, then obviously going back and reworking, so it adds a technical debt. So technical debt is one new word being used in Agile DevOps way of working. So where technical debt is rework. So at any point of time, if you find some defect in production and that fixing it, so it adds a lot of cost. As you go forward and starts finding the defects at later stages of life cycle, you start adding cost, and your time is also wasted in that. But if you catch defects here itself, during development itself, then it's better because the cost to rectify that, correct that is very low here. So that's why in DevOps we talk about the shift left approach. So deployments give control of deployment execution to the development team. Testing, do testing during the development phase. So bring such wastage kind of operations or activities to the left side as possible. So even environment provisioning. So this team, as we were talking yesterday, so environment management team, ops team, basically, they will use infrastructure as code, they will use cloud, they will use virtualization like VMware, and give automated environment provisioning with the testing team or with development team. So whenever code is getting deployed, before that environment is created automatically. The shift left approach is the key when you are adopting DevOps. Okay, coming back to continuous testing. In the continuous testing also we are trying to do the testing at the earlier phase. So But test automation, doing just test automation is not going to bring the purpose in case of efficient testing. So you need to follow the continuous testing approach. So we'll see further what are the differences between test automation and continuous testing. So in continuous testing, as compared to last slide's diagram, you see here we are testing everywhere, dev and ops. So when you say start from planning, so we test here. We test during branching, coding, merging. We test during continuous builds, basically CI process. Then we test during release also, during deploy, operate, monitor. So everywhere, test. So that's what means continuous testing is just not like you do test automation at some other point of time, but continuously. That is culture. So you are bringing that quality is the focus, and you are uh, doing quality assurance continuously. So testing early, testing often, test everywhere, automate. This is also key, means automation is required in continuous testing, but that is not the only focus. Changing the culture and bringing testing everywhere and then automating it. Like we are seeing in CI process, in this process, basically we try to bring unit testing where or you try to bring TDD, test-driven development, driven development, which we'll see today. So this type of development you are trying to bring in this phase. When it comes for release deploy, but when deployment is done, you are doing smoke testing in automated way, so that your deployment are successful or not, you understand that. So in operate monitor, you are doing application performance testing, security testing, those sort of testing here. So you are testing everywhere, and also you are trying that your production environment is sorry, your staging environment is as same as your production environment. And so many times in practical, we see the scenario that development team has done their development and everything is fine. So did deployment on dev and it's working fine. And developer goes home. Okay, now QA will do the testing. So deployment on QA has happened. But because your dev environment and QA environment and production environments are not similar, so there are deployment challenges also, or there are testing scenarios are also different, because what testing developer has done, he might have used some other library which is locally hosted, and he has referred that, and that's why it was working fine on his environment, development environment. And when it comes for QA, that is not available, and or in case of COTS product, so if that is not latest version is not available in QA environment, or it's not accessible, obviously there could be challenges, or some configuration of environment is not same, then you can see the defects. Uh, so to avoid such things, your all environments should be same, and that you will try to achieve with infrastructure of code. So you are having that configuration file, uh, environment configuration file, which will be same for all the environments to do the deployment, except host name and IP addresses are changing. So such things you try to bring in continuous testing. Okay, so let's see some of the testing facts. So in reality, we see that testing is more focused on UI based kind of testing. 94% testing is done on UI testing. So for functional testing or checking the UI. But when it comes for unit testing, API testing at lower level, so it's just 3%. Whereas what is goal and what should be actually, so unit testing, at least it should be 50%, at least 50%. So if you are able to do it 60-70%, that's still better. And then your UI and API testing, automatically it will become 5%, and API also should be 45%. So if this together is having a contribution of 95%, then your UI testing is just 5%. And this table shows as we go forward in life cycle, so requirements, so cost to fix and time detected. If you detect the defect at later stages, this much cost is incurred. So requirements related defect, you find during post release, then 10 to 100 times cost is there to fix it. If design defect is found during testing, 15 times more cost is. And building, so these are the figures, like 10 to 25% post release. So you need to see that you are trying to catch defects as early as possible, so that you are reducing the cost. So early you try to find the defect and fix it, it's better. And so this is also similar figure. So where unit testing, integration testing, and system testing, it will go gradually. So at lower level, you do the unit testing, integration testing, and then system testing. So these are some types of testings explained here, and coverage of this unit testing should increase as compared to your functional testing or UI testing. Why continuous testing? So some of the points you must have understood now. Why continuous testing? So more things like test plan, test cases, and scripts are ready as soon as requirements and releases are finalized. And catch the defects early. Reduce time to fix the defects. So if you find the defects early, obviously time to fix it is less because complexity is less, and the developer who is working on that currently is already doing that coding, so he is able to fix that, and a lot of resources are not wasted. Then estimate the test efforts early. So when you are in your sprint plan, your PI planning itself, sprint planning, release planning, there itself you identify the test efforts. So what are the user acceptance criteria? So you will try to define there, and then you will understand what we need to test and how it's to be tested. And reduce the rollback. So when you are building the product, if you deploy something in UAT and you have to roll back, then it adds again a lot of cost. If you are doing the rollback frequently, then it's not desirable situation for end user also, as well as business also. So try to reduce the rollback. How it is reduced? By again testing early, making development and staging and production environment similar, then doing smoke test or having kind of staging environment or like blue-green kind of deployment we have seen. So where you have a switch on and off your actual environments, and then you can avoid the rollback in real-time scenario, and make releases successful on production. So all these efforts, what you put in testing, operation, and developments, so that will make you your production releases, production deployments successful in continuous manner. So many of you must have seen and must have started using Facebook maybe sometime like 8, 9, 10 years ago. So have you seen any kind of downtime for Facebook? Or have you seen like any change? So there are a lot of changes. If you just try to remember how Facebook was a few years back and how it is now. So there are a lot of new features and capabilities have come. So those are so seamless that as end user, you are not knowing when it was released and how it was released. So that's the way DevOps works actually. So you have seen like you are able to share some Facebook link on WhatsApp. You just copy link and paste it on WhatsApp, and you see that you see that video in WhatsApp itself, and that shows complete description or what exactly that video is about and who is saying what. So that those details are shown, and then you just click on that and you are able to see it in through WhatsApp itself. So have you seen any announcement, any launch from Facebook that we are releasing such and such feature? It's so transparent. When it was deployed and when it is available as an end user for you, you don't know. And even some banking applications also. If you use some HDFC SBI kind of banking portal, you see that many things have come up. You even don't remember when it was released. So such things are possible because of DevOps. So, and each thing is important in DevOps. It's not just doing some deployment automation or doing some test automation. All these things need to do religiously and need to change the culture, follow the steps, and then you see the success. So let's see the differences in more structured way, automation testing and continuous testing. So definition wise, automation testing is more focused on the automation and tools, whereas continuous testing is a methodology which focuses on continuous quality improvements. So you start to imbibe that culture and start that focus right from your story writing or requirement definition. So there itself your quality as a focus and you follow it till the end. Then it's automation testing is more dependent on the machine and the tool you use. Whereas in continuous testing, the focus is more on identifying the risks and modifying software continuously. It's not. It will not depend on the machine or tool. Tool is just facilitator. Whereas this culture, human being, thought process is modifying the product in continuous manner. Then defects in automated testing, okay, less mistakes and defects will be defects will be caught. So whether you are doing automated testing or manual testing, so you are catching the defects. Only you are catching it in automated way. So less mistakes in catching the defect, but number of defects which are caught, those will be probably more when you do automated testing as compared to manual testing, because it's not dependent on a human. But in case of continuous testing, you see less defects because you are improving continuously. So in latter phases of life cycle, you will not see the many defects. And automation is implemented in automation testing at the end of each phase. And test last kind of approach, where in case of continuous testing, automation is throughout the process. And the big in automated testing software release, it takes months to get released because your testing efforts are a lot of and also those are happening at the end of the phase. Whereas here it's on continuously basis, continuously weekly basis basically. And feedback in continuous testing is continuously you are providing feedback. Our developer itself is getting the feedback. When you follow the TDD approach, you are continuously getting the feedback. And who is performing that? Dedicated testing team in test automation. So that's the one not that desirable thing from a project management point of view, that you are still need to rely on some testing team and which is dedicated. Whereas in case of continuous testing, it's part of testing is part of your Scrum development, and team itself is doing testing, and developers themselves are self-sufficient to bring in continuous development using testing approach. And what are the challenges to implement automated testing? So delays in testing skip due to release pressure, accountability with testers mainly. As it takes a lot of time, though it's done in automated way, it still it incurs some time. So that's why it's avoided, particularly when there is like a high release pressure. So some of the scenarios, it's assumed that okay, we have tested it in earlier stage, so let's not do it. It's working anyway, or it's more like experts advice. Okay, this if we don't test this, then this is okay. So such kind of things are seen during release pressure, and you skip the testing or delay the testing. But whereas in case of continuous testing, it is done continuously, so such challenges will not be there during release. But it needs high level automation, and team needs to own the quality of the product. Whole team needs to own the quality of product, not just testing team. So examples are functional testing and automated testing in case of automated unit testing, sorry. And for continuous testing, test-driven development, behavior-driven development. These are way of working nowadays in modern way. Any question?
Sir, may I?
Yeah, sure.
Is 100% testing possible?
No. Straight answer is no. 100% testing is not possible because there are challenges like uh, you can't test all the scenarios, or you need to virtualize some of the scenarios. And if you are having a kind of virtualization tool, or you are able to do that in the required time frame. See, time frame is also important. So if you are able to do that, then you can address that challenge. Or some of the technology factors are there which is not supported in automated testing. So such things are there. That's why 100% automated testing is not possible. But that's why if you go with continuous testing approach, and particularly TDD, BDD kind of working, then you are covering major testing scenarios which are which will get affected, or which will affect the product as major.
Okay.
Yeah. Any other question? Okay. So what are the different testing components? So you start with testing framework. Each organization, you'll see, they have their own testing methodology. They are having test competency, and which they come up with testing framework, which talks about what different types of testing they are expert in, and how are they having any assets so that they can be adopted for different clients, or there are any kind of experienced or certified people uh, who can be brought in, or there are what testing tools experts you are having, what testing tool partnerships you are having. So such things the testing framework will talk, which gives client confidence that okay, you are having good experience in testing. So, and testing framework will also give examples in all those sort of testings. And as you asked, Doctor, this question just now, how much testing I can do? Can I do 100% testing? But then you can tell to the customer, okay, in custom development, in web development, we have achieved like 80% of testing for so and so client in so and so domain. But when it comes for kind of system testing or IoT, so we are at 40%, but industry is at 30%, we are at 40%. So such things you talk because your framework is strong enough, and you have built up that based on your experience. So these all things come in test framework. Then when it comes for test management, then first it talks about what is the project vision, product vision. It talks about requirement document. Uh, and then when you understand the goal, uh, so if your business owner is saying that I want to deliver this product with so much quality goal, then that will be mentioned in the vision document. And test plan is created accordingly. Test plan will talk about some sort of detailing about the product, and what features will be there, where it will be released, and then what are the test cases. It will have a link with the test cases, and how defect management is done. So a lot of things are there. We'll see some examples of test plan. Then test automation, it talks about how much automation is covered for different kind of technologies, domains, uh, and application types. So that it will talk about, and what different testing tools are can be used. We are having expertise in that. So such testing tools. So a lot of testing tools are available in market, but again, each having its own limitations as well as advantages. So which you will try to leverage based on your requirement or application type. And then test scripts, so you write test automation scripts when like you use Selenium kind of tool, or IBM test platform, or HP UFT. So such tools, they have their own methodology of writing the test scripts that sometimes in Java itself, or sometimes some script based kind of language which you use and write the automation test scripts. And different types of testing. So we have seen unit testing in during continuous integration session. Then you are in smoke test and sanity tests. So which are like uh, you are doing very specific. Okay, if things are working at higher level, and then functional and regression test. Functional test is done to check the functionality of the product working fine. Regression test, any feature or any change is happening, you are still thoroughly testing the system, completely testing the system. And TDD and BTD, yeah, test driven development, behavioral development. So that is actually you start uh, writing the code itself in different way, and there are specific rules you follow, and tools like Cucumber you use where it helps you to automate the test coding also to the some extent. That we'll see. We are having 2 3 slides on that and see the demo on TDD also. Then performance tests. So you do performance test during UAT and production also. So how your product is taking the load, is it running well on the defined load, or even you do the stress testing also, or even breaking the tool. So that sort of performance tests are being done. So tools like open source JMeter is used, or IBM performance tester is also there. And then you obviously security test. So as I told in yesterday's session, so security is prime importance now, because there are a lot of instances where software are being broken, and there is a lot of, see uh, what happens when there is like security blockage, then loss is directly in monetary term. So somebody can steal money from your account, or even bank itself. Or it can create damage to your reputation, uh, and that is affecting your business. It's not very much desirable. So security is prime important. As in one of the organization, we have seen a ransomware attack. So many organizations actually they have faced this ransomware attack, and their major uh, work in the organization has gone down. Not only that, but many clients they question that okay, you even suppose like your banking clients and financial clients, etc. So they question credibility of the vendor, that how can you tell us that you will perform our software development securely, because we are giving everything in your hand and your systems are not secure. So such things happen because of these. If security testing is not done properly, and it can cause damage to the larger extent. So security tests are nowadays very much important, and security focus with DevSecOps. And people were talking about DevOps till this time, but now they talk about DevSecOps, development, security, and operations doing together as an integral fashion. And then measurement metrics. So what you will measure during testing. So that is also important, because you want to continuously improve on the product. So there are different types of metrics which are created in automated way, and those are monitored. Okay, so these are different testing components. Any question on any of this? So this is a test framework. So for, I think this, are you able to see this? Is it visible, this text? I'll read it out.
Sir, in case of automation testing, we get a choice to select the tools.
Yeah.
So, can you throw a light on how to select the tool like that? Means
Yeah.
there is
I think this is
always
good.
confusion whether to go with Selenium or whether to go with RFT like that.
Correct. Yeah. So this is good question actually. How to select the tools in DevOps overall? So you asked question about tests. So I'll try to answer it in overall way. How to tools in DevOps can be selected. But yes, specific, I'll take testing first. So tool selection for testing. Uh, so you know, first thing you need to see, like in this diagram also it is shown. So which type of testing you are doing. Okay, so if you talk about unit testing and this part, basically continuous integration part, then you need to see what are the different tool set available in the market at first place. Okay, what are the, then you will try to divide what are the open source tools and what are commercial tools, because cost is also one of the major factor. If IBM or HP, Microsoft, they are giving very good tool from functionality point of view, capability point of view, but still if it is not in your budget, then it's difficult to select. So you would first is which phase of life cycle you are trying to focus. So if you are trying to focus this one, then see what are the different tool set available. Out of that, which are commercially available and which are open source, and then try to compare tools capabilities uh, from open source and commercial both. And if capability wise, okay, you'll come up with, so you do like rating of the tools. So if out of all these tools you select 5 tools, out of that 3 are open source, 2 are commercial tools, and then you try to rate those tools 1, 2, 3, 4, 5, depending upon different parameters. So those parameters could be is it supporting, if you are using support Java, does it support Java? Okay, then second thing is, do I have expertise in that? So this is also one important thing. Does people from my team know that tool very well? If not, then I will have to enable them, I will have to train them, and it will incur cost. It will also incur time required to learn that. Then third thing uh, is it having, can it cover all sort of test scenarios which my product demands? So is it covering all those sort of things? Fourth parameter could be the cost. Fifth is hosting that tool. Is it cloud hosted, or it can be hosted in premise? And what infrastructure I would require to host that, and how I can integrate my application with that tool. So these are some of the example factors. So you would try to apply to those selected tools and rate those tools. And based on that rating, so you'll, out of 5, again, you will come up with like 2 tools. Okay, out of this, I can go for these 2 tools. And then you make judgment and based on those factors and select the tool. Is it answering your question?
Yes, sir.
Okay. And then accordingly, you go for next one and next one. And then you uh, accordingly select which tool is best suited for overall DevOps. So when it comes for other tools also in DevOps, so for deployment automation, suppose, you will apply similar parameters for deployment area and select the best possible tool. So when it comes like for uh, requirement like yours in college particularly, you would have to really see cost, because in our case, their client is budgeting that. So if we say that, okay, we'll go with IBM test platform, and client says, okay, I am having an IBM partnership and I get licenses at very cost effective manner from IBM, and I have expertise also, and IBM will provide me consultancy to adopt that tool. So these are some good factors from client point of view, and they will go with IBM platform. But in your case, you will have to really look expertise and cost and how you will host that, uh, and in long run, so how much time you will have to run that, then who will own that. So all these factors you will have to see and choose the tool accordingly. Okay, so coming to this framework, so these are different phases of life cycle, and according to the process, you will select the tool. So like requirement test, design, automation, and usability testing. So Gherkin or Cucumber. So Cucumber is basically a test-driven development tool, which actually can cover most of the continuous integration scenario. And then SonarQube for code review, code analysis, and resharper or check marks. So these are some code quality tools. And then contract test automation, microservices automation, service virtualization. If you are using microservices architecture, then you are having SOAP UI. It's very popular. Then JUnit, obviously, NUnit, JUnit, depending upon Java, Microsoft development, and dev test kind of tool. Then Azure DevOps and Azure Pipeline. So those are integrated with other tools so that you are having CI kind of scenario. Build analytics and verification testing. So you can bring in. And then continuous improvement feedback. When it comes for test automation latter part, non-functional requirement testing or QA, then there you can bring in Selenium and then again check marks. And there are other, I mean, say HPUFT fits in here also, so it fits all in these pages. Or IBM test platform, it also fit here. Then JMeter for performance testing. If you are doing mobile development, then there are different tools for mobile testing. Yeah. So, but overall, commercial tools like Microfocus or IBM or HP, Microsoft, they come up with all sort of existing technology supporting, but the only thing is cost. License cost is at higher side. And here you see testing types, tools, and all these test plan, test cases, test documents are also part of your test framework. And how to achieve or implement continuous testing. So first you implement continuous integration. There you have integrated test management. So your test cases are created early and you are having those test scenarios traceable from your development. And then automated test entry and exit criteria. Then automated unit and integration testing, test virtualization. So test virtualization is one again interesting and desirable scenario, but many people don't understand that actually what is its importance. So suppose you are having a component development kind of scenario where our application, different applications in your as a whole, or if there is microservices also. So you are having 10 services, and out of that, one service is still in development and dependent for your testing. So in that case, you virtualize that service. So this test virtualization tool, it will support the scenario that you can, suppose you want to, in what way you are dependent. So application A you are testing, application B passes some data point, some data which is used in application A. So that sort of scenario is there, testing scenario. But as application B is not ready, so that how will you get that data? So you can virtualize that application B component so that it will just pass on that data to the application A, and your application A testing will be complete. So that sort of test virtualization you can do with test virtualization tool. Okay. And then dedicated test automation resources in the form of tools, machines, and people also. Then automated deployment is also one key thing in continuous testing. Unless you have that, you will not have complete automated process handshakes, and QA gets defined, and persons who are responsible for approval, etc. So they are forced to come in the process and do their activities. And traceability with requirements, that is also you need to implement, and this ALM kind of ALM CLM tools, which is like application lifecycle management or collaborative lifecycle management, it's called as. So it brings in all sort of traceability. So nowadays this word is also very popular, application lifecycle management. So where whole lifecycle you consider, and you are doing management through different ways by process handshake, process integration, automation, and traceability. And then defect management. So this is one important process you need to implement in continuous testing. So defect management talks about how defect is submitted. Uh, when defect test during testing defect is found out, so it's submitted automatically. Then it's assigned to the owner. Also, it has captured the required data that which release, which application, which build defect has found during which test case testing, and which step has failed exactly. So all these things will be captured during defect submission, and it will be assigned to the owner, and it will have state like defect submitted, then assigned, and then uh, resolved, or work in progress, then resolved and closed. Such defect life cycle will be there. And when it goes to fixed or resolved state, then testing team again does that testing and defect is closed. Or if it's not resolved that time, testing again fails, it is reopened and reassigned to the developer. And such metrics you try to capture them. How many defects are reopened, or how many defects are for particular application. So how many are high severity defects, how many are high priority defects. So such measurement metrics you capture, and according to that your product quality is decided. So this is one example of like IBM Rational Quality Manager tool. So how test plan is there. So this tool actually is for quality management, and it integrates with other test automation tools, not just IBM, but other Selenium or UFT, HPUFT, those kind of tools also it integrates, so that your complete continuous testing way it can be applied. So when you do the deployment on environment, then it will have task as a process, deployment process, that when deployment is successful, it will trigger the test case from this test plan. And then automatically the test automation tool will do all sort of automated testing. If testing is failed, it will again submit the defect in your Jira or Rational Team Concert or any sort of your development tool, and it's assigned to the developer again. So that sort of a whole complete lifecycle feedback loop is created using such tools. So Quality Manager is one of the tools in that continuous testing. So it has, so what test plan actually has, so these are the different links in this. So summary, then business objectives, as I said, so your business goals, business objectives are mentioned in test plan. And what are the test objectives? Then requirement collection links. So you are having traceability of requirement with the test plan. So what you are going to test, which requirement you are going to test. So that link is mentioned here. And then you can go back to that requirement to see more details about that. Then development plan links, then risk assessment, test schedules, estimations, test environments, testing. So all things are there. You will see here, test case is also there. So test cases are actually the test scenarios you write in that. So how you are going to do the test. And then the test cases in turn have test scripts, which actually run manual or automated way. So test plan is this document which mentions all this data. So in the tool kind of quality manager, so you can just go on clicking on these links and fill in the data there. Okay, and it will have its own life cycle. It will have reviewer also, so that it will test manager will review the test plan and give his feedback, and then it will be ready for implementation, adoption. And this is test case, quality manager again. So test case will have test script, apart from other things like test case design, development items, requirement link, it will also have here in precondition and post condition of the test case. the entry and exit criteria, and then expected results out of this, which test script are you going to use, and then test case execution records. So all these scenarios details will be captured in test case. Excuse me. So from here onwards, we'll see test-driven development in brief. So test-driven development is popular when you are using in agile way. So doing development in agile way fashion. So what are the steps in test-driven development? So first step is consider a code module that is to be written. Write a test, run the test. So you start itself by writing the test. So you are not writing the code and then it will be tested, unit tested, not like that. Here itself, it's like you are writing the unit test case itself. And you first write it, run it, then obviously it will fail first time. Then you go on improving that on that. So then write minimum code possible to pass the test. To give an example, suppose you are writing some code to just print the message. Okay, so the requirement is like message of end user should be print on the screen. So any message I enter as an end user, so that should be printed. So that is the requirement. So how it will be done? So first I will write the code to print hello world message or some simple message, specific message. And then that once that code is successful, then I will improve upon, refactor that code to make it like kind of subroutine, and then end user will able to enter his own message and then it will be displayed. So I'll go on improving as go forward by improving the code. So first please write the test. Then so during testing, what do you do? If there is a module which print the message, so you will type the message hello world and then it will return that message hello world. But here itself, first module I am writing to print the hello world message, and then improving that subroutine to take any sort of message and print that. So these are the steps you follow during test-driven development. So first you do the clean coding, then write a failing test. So your test will fail obviously because any message is not getting typed in that requirement. So test the fail, then improve the code, then it will pass the test, then again refactor the code. So this cycle you follow and you go on building step by step on that requirement. So this is called as test-driven development. So how is TDD approach? So this is the flow of it. Write the test, then check if the test fails. If it fails, then write code and make the changes. If it is not failing, then write another test. If it is failing, write the code to make the test pass and check if all tests are passing. And yes, if refactor the code to make it more universal and repeat it for other development work. So first time it will obviously fail. So this will be coming in picture at later point of time. But initially it will fail and then you go on improving upon your code. So when to use TDD? TDD is development methodology based on continuous testing. So as you see here, you are doing continuous testing. Your developer itself is writing unit testing and he is doing testing itself himself. So it's like a continuous testing approach. Then in TDD, design emerges during development. So if there are any challenges or you see a requirement change or any design change, so it's emerging during your development work itself. Then TDD used at unit integration and system level. So even you can do it at, so as you go forward, it will automatically fall upon integration testing or system level testing. So used in agile way of working. And then test automation tools expedites TDD. So tool like Cucumber, there are other TDD tools, so they expedite your this TDD kind of development. And acceptance test criteria based TDD is done to meet acceptance tests. So acceptance test criteria itself you are trying to fulfill during initial stage itself. Then BDD. So there is little difference between TDD and BDD. In behavior development, you are writing the code first in the form of like plain English. So you, as you see the software behavior or as the requirement is, you just try to break that requirement in the scenario as end user will see. So if like I want to withdraw, so the storyline is like users should able to withdraw the amount from his account. Then what user will do? He will log in. If it's in like net banking, he is logging in, putting user ID password, then checking the balance. And if there is 50,000 balance in my account, then I want to withdraw 10,000. So or transfer 10,000. So I'll transfer that amount. So such steps as the end user I do, and I write the test case in test script in that way. So similar way, such steps are written in the code in plain English with your variables and data points written clearly. And once that test scenario is passed by tool like Cucumber, then automatically that subroutines, functions, etc. So those type of code methods are basically created, and then you write your syntax into that, and that's why test will not fail in that case because you have already generated the test scenario during behavior development. So in behavior driven development, you are writing the behavior of the end user or the system that is expected. So tests are more user focused, and before you do the code, TDD and BDD are written. So before you start the coding, here directly you don't jump on the code. Then it's continuous product improvement process because you are doing it testing continuous fashion, and aligned with user acceptance criteria because you are keeping user as end user as the focus. And test cases are written in common plain English language. So that's why it's easy to understand for non-technical persons. So business who is getting involved, and as they are not like every business owner will not know all the languages. So when you write such development scenario, they will also be able to understand it quickly, and they will give you inputs on requirement whether that requirement is right or wrong. Then brings collaboration between technical and non-technical teams. So this way basically what I explained. Any questions? So this is example of BDD. So how is the framework? So given some initial context, when an event occurs, then ensure some outcome. Okay. So story could be, as a customer, I want to withdraw cash from the ATM so that I do not have to wait in line at the bank. So what is the scenario one? So I'll write the test case like this. Account is in credit. Given the account is in credit and the card is valid, and the dispenser contains cash, when the customer requests cash, then ensure the account is debited and ensure cash is dispensed and ensure the card is written. Okay, and scenario two, account is withdrawn past the overdraft limit. If sufficient amount is not available in the account, and given the account is withdrawn, card is valid, the customer requests cash, ensure a rejection message is displayed, ensure cash is not dispensed, ensure the card is written. So such scenario you write first in the tool like Cucumber, and then when you run this test, you will be able to write the code also according to this scenario. But for this type of development, you need to really factor down your development work. So as granular you can make the requirement, the storyline, so that will be better. If it's like a large scenario, you write as a requirement and you try to write the sequence which is like 50 or 100 lines, then it's difficult to do. So it should be in small parts. So this is we just saw. So step one, write a high level business value in Cucumber or RSpec, Capybara kind of tool. So it will obviously, it will initially fail. It will go red, then write a lower level and then implement the minimum code to pass the lower level example. See it goes green and then write the next lower level. And go on repeating these steps, steps 3, 4 like that, and it will develop your complete code. So I mentioned here some test automation tools again. So for unit testing, and TDD, BDD, functional testing. SOAP UI is also one of the tools which fits across this actually in this. Then performance testing using JMeter or IBM performance tester or IBM test platform. And security testing using these tools. And mobile testing using IBM Codicon. Okay. Then this one more thing actually I wanted to cover. So it's not just related to testing, but overall DevOps. So what are the different types of measurement metrics you will have in DevOps? So on your dashboard, your reporting. So project health, you will try to capture cost, schedule, effort variance, and resource utilization and technical depth. So technical depth, as I said, it's about capturing the amount of rework you are doing. And if your testing is not continuous, obviously your testing technical depth will be large. Technical depth actually it adds cost to the project because it's rework, and it adds satisfaction for the end user and customer. Velocity, so burn down, burn up charts. So these are agile terms. So how many story points are completed? How many story points are not completed? So such type of charts are there related to story points in a sprint or in a release. So those are called as burn down, burn up charts. Then throughput, again, it's related to story point. The lead time, how much time you are taken for fix something or deliver something is the lead time. Then resolution rate, so how many defects are resolved or how many hot fixes are resolved in particular time, so such resolution rate. Then build frequency, how frequently you are building, its daily frequency or weekly, monthly, nightly, and how many builds are successful. So build frequency related to build results. Then deployment frequency, average deployment time. So how much time each deployment is taking, average of that. And then product success, how will you measure the success of the product? Customer satisfaction. Nowadays, you capture customer satisfaction using some tools like which takes customer input. So many times we see when we do the WhatsApp call now, video call, immediately you get that notification, and you need to select how many stars you give for the quality. So that will that data will give customer satisfaction. Or if you when you get pizza delivery at home, immediately that boy while going he says, "Sir, you will receive some message and give you a response." So there are like smileys also sometimes. So you, if you are happy, you view that smiley. So such number of smileys are captured. If you do some online shopping, there also you get such a satisfaction index survey. Or there are sometimes 3, 4, 5, 10 question detailed survey, and that way customer satisfaction is captured nowadays, and it gives product success. Then revenue increase, obviously. So this is important thing. So how many revenue has increased? So though you are using Agile, you are using DevOps, and very well you are able to manage the product release. But if it's not going to increase the revenue, then it's of no use. Then cost of quality. So that is another product success criteria. When it comes for QA, number of defects submitted, defects reopened, defects rejected, defects leakage, defect density. So there are different metrics in case of QA. And then build failures, failed deployments at each state. Then MTTR, MTTF is like mean time to recover and mean time to failure. So when your application is failed or deployment is failed, so how much time you have taken to recover, and the average of that is called mean time to recover. Mean time to fail. So when was it last failed, and when is failed, or if it is failed now, so what is the mean time of that? So mean time to failure. Then infra utilization, how much you are utilizing. If you are, as you are investing in infrastructure, so is it used effectively? What is its utilization that is calculated here? And then security failures. As I said, security cannot be compromised. So it is affecting cost, your reputation. So security failures also you will measure in different ways. Any question on measurements? Okay. So this is about continuous testing. And now next I'm going to talk for 10-15 minutes on security testing. Okay. I hope it's visible. I have shared another PPT on security testing. Okay, so what is security testing? So security testing is software testing that uncovers vulnerabilities, threats, risk in software application, and prevents malicious attacks from intruders. So how vulnerable is your software? So if it's like, so to take a simple example, if you are having a good user management kind of module developed, so anybody needs to log in. So as soon as you have that application open, you need to put user ID and password. You need to register and user ID password. But if your password is not having all that criteria defined, good password, bad password kind of criteria, so that there is one uh, capital letter, then there is some special character, some number, and it's not word from dictionary. So all those parameters, if you are not applied, then it's very easy to break that application, that software, because software, passwords are weak. So such vulnerabilities could be there. Or if it's running without running HTTPS, then obviously it's vulnerable if it's running just on HTTP, because it's not secure protocol. Any software testing tool will try to exploit such vulnerabilities and try to detect it. Then threats. So what could be the threats? So that is also part of security testing. And risk in software application. So you try to identify the risk during the requirement. So that's why continuous testing, why we talk about. So when you are writing requirements, there itself you try to identify the risks related to that requirement, and then prevent malicious attacks from intruders. So intruders are there. So as it's like when queues are there, police is there, queues are there. So that will never end. So malicious attackers, intruders are always there. They are trying to always see where they can exploit and get into the system and break the system. So preventing that is very important. Uh, so software testing, security testing will try to cover that also. Then the purpose is to identify all possible loopholes and weaknesses of the software system. See, the security domain is very actually important domain nowadays because of very much security threats we see for software now and then, and we see many spam messages actually in your WhatsApp or in your mail that okay, this and this team is going to attack so many servers and your system will be broken. Or if you get such call on your mobile, then don't open or don't receive that call. All your data will be stolen and that. So those are like spams. But such threats are there. Uh, and you need to be careful, particularly people who are using net banking and old age people. Uh, so who are not very much conversant with the newer IT world, and they succumb to such weaknesses of software, and it's always not desirable. And also we have seen some software which can get your details and like mobile or your fingerprints kind of, and then use that maliciously to affect the system. And what can cause your software security hazards, like can have loss of information, revenue, repute at the hands of employees or outside the organization. So this is the DevSecOps figure. So DevSecOps itself is like a complete different sort of viewpoint nowadays. Uh, so I'll try to brief here. So So in case of planning, requirement, design, build, test, so like normal software development scenario. So you try to, or you bring in basically this security posture right from the start. So understand security posture, define control gates, risk assessments. So when you are writing the requirement at that time only, you would identify the risks associated with that requirement from security point of view. So the other risks you will obviously identify, but security related risks you will identify, and accordingly you will have your design uh, taking care of mitigating those risks basically. And also you will have control gates defined so that at each stage in software you are closing that loophole. Then in this phase, threat modeling, secure design review, secure design. So based on this scenario, we will bring in all these things during your architecture and design phase. And when it comes for build, this SAST and DAST, that you will bring static analysis and dynamic analysis. So those sort of security coding guidelines you will try to bring in, and you will use tools like checkmarks, sonar, etc., to test such vulnerabilities at early stage itself. And then during testing, you will have security testing, vulnerability assessment, penetration testing, platform assessment, periodic testing, all these you will have during test deployment and maintenance kind of work. So you will do this on staging as well as pre-prod and production also. So you will do this security testing, and whatever inputs are there from this, all this threat modeling, threat security testing, those will be inputs to your test scripts, process standardization, better coverage, and so this will go again in your planning and requirements part. So you are closing all this loop. You are doing threat modeling, automation, vulnerability database, RASP, and then industry best practices you will try to bring in. So all these you will try to bring in as your database and improve upon that. So security, see in DevSecOps, security is means again throughout the life cycle. So you are not doing test, so security testing at the end or on production. You are doing some vulnerability checking and fixing that. So you are not doing that. It's right from your start itself. It's your focus. It's your culture. What are different types of security testing? So vulnerability test scanning, scan a system against known vulnerability signatures. So when you use some sort of security scanning tool, so it has all these known vulnerabilities, and it will scan your software according to that. So security scanning, it involves identifying network and system weaknesses. And penetration testing, it will actually try to intrude your system. Like a malicious hacker, it will try to attack the system using the loopholes, so no loopholes. Then risk assessment, the testing involves analysis of security risk observed in the organization, and risks are classified as low, medium, and high risk. And security auditing, so it will be according to the audit rules, it will inspect the system. And ethical hacking, so you'll bring some ethical hackers to hack the system using again their own tools and knowledge. And posture assessment, it shows an overall security posture of an organization. If you remember earlier 95, 98, Windows 95, 98, if anybody has used it, so it was not having any user ID password. You just enter and you are in the system. So that way Microsoft has started. But now if you see these modern systems, so Active Directory enabled and that, so it's a very much secure system as compared to earlier. So what are different security testing roles? Hackers who access the computer system or network without authorization, though they are not having any user ID password, or though they are not part of your organization, still they will try to get into the system. So those are hackers. Hackers break into the system or steal or destroy the data. So they will not just log in, but they will destroy the data also. They will do the damage. And ethical hackers performs most of the breaking activities, but with permission from the owner. So in one of the movies, we have seen that, right? That Wednesday movie. He was like an ethical hacker, and he works with police and try to get data from the terrorists. So such ethical hackers who help police or organizations to help to improve the system security, because they know the techniques, how systems are hacked, how penetration is done into the systems, how those are cracked. So such ethical hackers are there, and script kiddies or packet monkeys. So these are inexperienced hackers. So they just learn something, and yeah, I know Ethereal tool. So I have used that in my organization, Ethereal tool. Okay, I will use in my society, and they will just start install that Ethereal and then try to capture some packets, and with here and there some knowledge, they will try to get into some systems. Their intention is just to do some sort of mischief. So such script kiddies are there. So what are different security testing tools? This Open Web Application Security project, this is having a Z attack proxy penetration testing tool, or dependency checks against known vulnerabilities. This is open source, I think. Then Wireshark, this is network analysis tool. Then W3AF, that is Web Application Attack and Audit Framework. Then IBM Security Analyzer is there, and SonarQube for early security analysis. That's it. I have any question on security testing? Okay, I will take you through some videos now. no continuous testing, and then TDD. Okay, this video is on security scan. So we'll see this first and then other videos.
Welcome to this short video overview of IBM Security App Scan Standard, in which we'll configure and run a simple scan and take a look at the results. From the App Scan welcome screen, we'll create a new scan, and from the list of predefined templates, we'll choose the template configured for scanning the App Scan demo test site, which you can use yourselves. The wizard opens and checks the connection to the site being scanned. We'll be using the wizard in this demo because it simplifies scan configuration by guiding you through the basic options. But when you're more familiar with AppScan, you can use the configuration dialog box, which lets you fine-tune many additional settings to the specific requirements of scanning your site. The next stage of the wizard is to record the login sequence with a valid username and password. This helps AppScan identify when it's in or out of session, and also enables it to log into the site if it gets logged out during the scan. When you've logged in, click the I am logged into the site button to close the browser, save the login sequence, and continue with the wizard. The green key icon shows that AppScan has validated the login sequence. In the test policy step, you can choose the kind of tests that will be used in the scan. We'll use the default policy this time. Then we'll start a full automatic scan. No FFW. When the scan's complete, which for a large site can take several hours, the results are presented in 3 views: data, issues, and tasks. Let's take a brief look at each of these views. Data view. The default view shows the structure of the site and other application data gathered when exploring it. The application tree on the left shows the structure of your site with all its explored folders, URLs, and files. You can use this tree to check that AppScan covered the site fully, and if necessary, change the scan configuration so it does. Click on a folder to open it. A node with a strike-through indicates a failed request. Right-click on a node for a variety of options, including Show in Browser, Manual Explore, Exclude from Scan, and a security report for that specific node. When you select a node, in the application tree, the result list shows the requests, parameters, cookies, scripts, and other details that were discovered during the Explore stage for that node. Right-click for various options, such as Exclude this parameter from the scan. The Details pane gives full details of the selected result in the result list. In some cases, you might choose to explore the site only without testing it and then review the application data. When you are satisfied that you have the site coverage you want, you could then continue with the test stage of the scan and then review the issues found. Issues view is the central most important view. This is where you can see details of the vulnerabilities found in your site. For each node in the application tree, you can see the number of issues found, and in the middle pane, the issues for the selected node are shown with their severity categorized as high, medium, low, or informational. When you drill down to a specific issue, the Issue Information tab on the right offers a number of details about the issue, with a rendering of how the test response looks in a browser and a simulation of any pop-up that the user would have seen. The Advisory tab has a thorough description of the security issue discovered. The Fix Recommendation tab offers suggestions for fixing your site, and the Request Response tab lets you see the actual request sent and response received. The third view is Tasks, which lists suggested remediation tasks arranged by severity to solve the security issues found by the scan. For each task, you can see the issues it addresses and the parts of the site that are vulnerable. AppScan offers a range of customizable reports, including a comprehensive security report and over 40 different templates for industry standard and regulatory compliance reports. There's a powerful, extensible SDK, and our accompanying Glassbox technology can reveal more information about issues, including identification of the exact problem in the application source code. We've seen some of the main features of AppScan, but there are many customizable options and capabilities that we didn't cover. AppScan is a powerful tool for ongoing risk assessment, both before you deploy your site and once it's live. This concludes the overview. Welcome to this short
Okay, so I'm just doing next video sharing. So this video is about using Cucumber for TDD.
Test-driven development class. We're going to quickly follow a few steps here. We're going to take you through from beginning to end, writing a story down to defining acceptance criteria, writing unit tests, creating code, and then having those tests pass. And we will show how you might automate those as well with a tool like Cucumber in this case. So to begin, we've already moved along. This is sort of partway through our class. And what you'll see is we already have an application here. This is an airline. And at this airline, what they're trying to do is allow customers to register to be frequent flyers. So we have a one story already there, and we're going to create another one, but we'll just show you one that's already existing first. So this is the feature called Register Member. As a customer, I want to register for frequent flyer program so that I can start collecting miles for perks. And within that, we have a few scenarios. The first is our happy path, a valid registration. So a customer registers, he's got a username and an email, and there's no real preconditions to this. And then what we're going to try to test for is that the member does exist with that same username, that member has red status. And the way we're doing this is the status goes red to green to blue to gold. And he starts with 0 year-to-date miles, but then he also has 10,000 mile balance, which is a bonus we give all new registrations. So these are some business rules we've put in here, and we want to make sure that they pass. And then other scenarios, we don't allow for existing usernames. In this case, we have a precondition. Given a customer who registers with the username Bob, when a customer registers with username Bob, then we expect to see an error message, a duplicate username. And then we have another example where we have invalid email. In this case, we want to be able to do a few tests with different types of invalid emails to make sure that in each case we get an error. So this is an example of some acceptance tests. This is automated, and we will be automating our own in a sec, but just to show, if you can run this, and what you'll end up with is a little kind of output of all the different tests, and at the end it just sort of gives you a summary. So there's 5 different scenarios, all of them pass. Within that there are 14 steps. A step is defined as each line in here. So this is a quick demonstration of one that already exists, but we're going to build our own sort of from scratch to sort of complete the whole cycle. So let's begin. We would like to now add the story where when a flyer actually takes a flight, that his miles are recognized and his status can be upgraded. So what we're going to do is take a look at a feature just like this one. So I'm just going to copy it and add it. But this one I'm going to call, and this is just a plain text file. This will be a feature called complete flight. sounds good enough. So I'm just going to say complete a flight. If I open up that feature and start from scratch, we start these things with our story. So we have a feature. I'm going to call this complete flight. Quickly come up with a story as a member. When I complete a flight, as a member, I want my miles registered so that I can gain, or I guess accumulate points and gain status. So there's my story. Now, once you've created a story, what we've pretty much done is the first bit. If you go back to my little diagram here, we've captured value. And the next step is to define acceptance. Now, I might leave this for a while like this until it comes time to getting closer to actually to implement this story. When we get closer to a sprint, we want to bring it in, we start to define acceptance criteria. Just like you might on a card, on the back of a card for these stories in the product backlog. So what we're saying here is, why not just use it in plain text in a situation like this? So we're going to create a scenario here. The first scenario will be, I would like to accumulate miles. And I could even test a few things here. So I want to accumulate miles and earn status. That's my scenario. This is where we use the familiar given, when, then template. And in this particular case, I want to be able to reuse things that I've done in the past. So we want to be able to do this. I want to register somebody. I want to maybe start them out with a certain number of miles, and then have them take a flight that will maybe push them over the edge. Now, in our case, you start out as a red member, and we're going to move you to green, and that takes 25,000 miles. So what I would like to do is just sort of borrow one from a previous one like this. So given a customer registers, and I'll start this one the same way. So given a customer registers with username, let's say Bob, and an email, bob@improving.com. And I can also put in other preconditions as well. And I could say Bob has, let's say 20,000 miles already. When he completes flight. Now, we could do this. We have a lot of leeway here. And I could actually say when Bob, maybe. When Bob completes flight, I could just say a flight that has a certain number of miles. I really want to use the language of the business here. So if they've already got some test data and stuff, and we actually do have one, there's a flight that we have stored here, which is from Los Angeles to Sydney, Australia, which is almost 7,500 miles. And the flight is QF191. So given that this is some flight data, I can just put in that flight. So completes flight QF191. Then what I expect is that he's going to earn those miles. So then I could say, and again, these are called steps. I want to be able to use some of the steps that I've used in the past. So we've already got a bunch that just measures their status when we did the registration piece, where they started with red, they had 0 miles, 10,000 miles when we just went over. So I'm going to just borrow this. So if I said something like, then that member has green status, which means he got upgraded, and that member has, now that he's already he had 20,000 miles, we want to know how long that was. I think it was 7,490. So he should now have 27 490 year-to-date miles. So given that that particular flight is 7,490 miles. Now, given that he started with 10,000 miles for his balance, this is what he can spend on. I'm going to make this 37,490. So this is just test data. We'd be working hopefully very closely with business, customers, product owners. This is in plain English. So hopefully they're the ones that are going to be able to do this. We will work closely with them when we first create this. We'll get the data in there. We're trying to create a realistic scenario in a class like this. And eventually I would like them to just take this scenario and make all sorts of different scenarios. We'll do all the plumbing on the development side, and they're going to be able to try all kinds of different scenarios where we go from red to green, green to blue, right on the thresholds as well, all kinds of things that we can do in this case. Now, this is a test. This is just text, but what Cucumber does is by using this gherkin syntax, it makes it very readable and easy to use, but then we also want to do is turn this into an automated system. So you can start that by doing just like I did before. I can run this as a Cucumber feature. Now, we really haven't done any work yet, but what Cucumber does is it makes it very easy for us. It'll just recognize that we haven't done any plumbing. We haven't hooked this up. This is just some text we came up with. We haven't hooked it up. So it'll repeat the scenario, but then what it'll do is say, hey, we notice you don't have any plumbing behind the scenes. And it actually will provide you with the code. Now, all we've really done is added 2 new steps. The others we borrowed from previous ones, the registering of users and the checking of these members. So really what we're talking about are these 2 steps. Starting somebody out with a certain number of miles and then having them complete flights. And it recognizes that down here. So it provided us with some code. And now our job is fairly straightforward. We need to create a class and put that code in it. So I'm going to go ahead and create a new Java class here. New class. This is sort of the code behind a step definition file for Java in Cucumber. And I'm going to add it to our features package. And this will just be called complete flights. It really doesn't matter what I call it, but I'm going to make it specific. And we have our own convention here. We call the previous one register member steps. So this will be complete flight steps. I'll create that. I'll put the code that they gave us right into it. Oops, didn't grab it. Let's copy that. Copy that. Then I'll dump it right into here. And it'll actually compile, and then it shows us these are the actual methods.
So you must have noticed in that video, so how he just written first like plain English steps, and then Cucumber created the methods class for it, and then now coding will be done according to the method suggested by Cucumber. So that way means you are first passing the test and then doing the coding. Yeah, let's see more on that for 5 minutes more.
So what it's doing is it recognizes that we were passing in some variables like Bob or the username and the number of miles. And that's what it sends into our methods right here. So we know that the first one was a username, and that the second one was just the number of miles we want to start them with. So this is the has miles test. This one was completing flights also with a username, but this second one was a flight number. We'll put that in there. Our job now is, and it defaults to just throwing an exception, but our job now is to connect to the API of our system. We have a controller facade class. We have the ability, we might be actually going to a remote system through a web service. However we need to do it, this is where we could do it. We're essentially replacing a UI and how it might do it so that we can write these tests before we even create the UI. So we need to connect to our system. In our case, we have a system and called TDD, and I'll make an attribute for it here. It's called TDD Air application. This is our app, and we get access to it this way. We created a singleton just for the purpose of our tests here so that we can get access to it. So when anyone, if anyone says that they have a certain number of miles, then our job is to give them those miles. And what we're going to do for that is make a dummy flight. It could really be from anything. So I'm just going to say from Dallas-Fort Worth to San Antonio. And the mileage will be the miles that they want us to start with. And the rest is just test information. I just call this test 200 if I want, but that's essentially the airline, the flight number. So what we're saying is, if somebody says they want to start a particular user with a certain number of miles, then what we're going to do is we're just going to create a flight that long and then have a member take that flight. So we have an API for that. So we're just going to say this particular member is going to take the flight test 200, because it's the airline plus the number of the flight in here. So what we'll have now is, after this is called, we have a user that we registered will end up taking a flight that takes this however many miles they pass into here. So essentially what we're doing is we're just hooking up the API to the test, just like a UI would. And then anytime they write a test around completing flights, we're going to go back to our application and have them complete a flight based on the username passed in and the flight number passed in. So this one's pretty straightforward. So once again, just to connect the dots, when a given username registers, this is going to go to a previously created step file that we did over here that registers that member. When we want to just start them out with a certain number of miles, then what's going to happen is we are going to create a flight with that many miles and then tell the member to take that flight. Now they have those miles. And then finally, when that person completes that flight, so they pass in a username and a flight number, well, we're going to just tell them to take that flight. So this doesn't actually work yet. We haven't implemented anything. We just had an API. So I could run this, and what I expect to see are errors. So it says I have 6 steps, and most of them failed. So my scenario is failing right now. It's doing things like it's measuring green status. It wants that member to have green status, but actually it has red status because nothing's really working.
So it's a long-term video, so it's time duration video, it's 40 minutes. But yeah, so this is the basic I wanted to just show. So how test scenario is written, and then develop the code and go on improving that based on, like, first you will fail, but you go on improving on that, and then you have that test case successful at the end. So that way it's done. So now next video, I'll just show that will be the last video on testing, that is continuous testing using Jenkins and Selenium. Basically, I wanted to show you Selenium also. Yeah.
To download Selenium. The latest version is 3.8.1, but if possible, try using Selenium 3.3.3, right? Because that's the latest stable version, and that's what even I'm using personally. And once you have downloaded Selenium, the next tool that you have to use is TestNG, right? So you don't need to download it through the internet like this from your browser. You can just specify the different dependencies and the libraries where it's present in Selenium itself, and through that you will get it downloaded. Okay, no worries. So tool wise, the next tool we have to download is Jenkins. So again, let's just say download Jenkins. Okay, and when you hit enter, the first link again, download Jenkins. So from here, you can download Jenkins also. Once you've downloaded all these things, you have to ensure that you set your Java path. Okay, but before that, if you don't have Java on your system, so just type in download Java, and you can download it easily. Okay, so just go to Oracle's official website, Java SE runtime environment, and from here you can download the latest Java version. Okay, so the version is 9.0.4. However, I've used Java 8, so it's fine if you're using 1.9 or 1.8. And once you've done with downloading Java, you have a simple task of setting the class path and the environment variables. Okay, you have to do this for Maven, you have to do it for Java itself, and you have to also do it for Jenkins. Okay, so how do we do it? It's again simple. Just go to my computer, right click, properties, you get advanced system settings, right? So click on this, and from here go to environment variables. Okay, and over here you have to specify the path for Java home and Maven home. So this is the path where my Java is present. Okay, and similarly, if you download Maven, then you have to specify the path of Maven, right? The root directory of Maven. So that's what I've specified here. And when you've done that, you have to come down here to system variables, and in system variables, you will find path. So over here, you have to again set that same path /bin. Okay, as you can see here, /bin folder inside the Apache Maven root directory is where you have to specify over here, and you have to do the same for Java also. So my Java path is set over here, correct? So these are the things which you have to do to ensure they are working. But however, if you've done it, well and good. So I don't want to waste any time. Let me continue with my session and go back to Eclipse. Okay, so from Eclipse, let's get started. Okay, so the first thing I have to do is create a Maven project, because my Java code or my Selenium code will be inside that project, right? So the structure, if we want to maintain, then we have to first go to file. So go to project under new project, and over here from the options, choose Maven project. Okay, under the Maven drop down, click on next, and here let's just say I want to create a simple project. I'm checking on that box, and next. So here we got to enter two details. One is group ID and the other is artifact ID. So let's just say selenium.maven.testng. Okay, and again artifact ID we can give something similar. So let's say maven.selenium.testng.jenkins. Okay, so let this be our artifact ID, and what these two are I will explain later. And then let's give a name to this, and let's say my project name is Eureka Demo, and I'm going to say finish. And as you can see over here, there's a new project directory that's created, right? maven.selenium.testng.jenkins. So if I click on this dropdown, you can see that I already have a number of items already over here. One of them is the pom.xml file. Okay, so this XML file is the file I was talking about, and we have few other packages over here. We have src main Java, we have src main resources, we have src test Java, and src test resources. So these are project directories again, and over here I can create multiple packages and multiple Java classes inside those packages. Okay, I can do that. So first of all, let's write our Selenium code, okay, and figure out what we want to actually test. So let me write a small code for that purpose. So for that, let's just go to src main Java, and I'm going to click on new and say class to create a new class. I'm going to give the name, okay, let's say Eureka Demo. Okay, and I'm going to say finish. So first of all, let's get started with writing our Selenium code and figure out what we want to actually test. And to do that, we have to go to src test Java folder, and over here, let's create a new Java program. Okay, I'm going to say new, I'm going to say class. Let me give the name Eureka Demo, and then let's say finish. Okay, so you have a simple program that's created. Now what we have to do here is, so here let me write a method. Let's say public void, and let me give the name test. Okay, so this is going to have the annotation. Okay, and when I give the @test annotation, I'm basically making this a testng test. Okay, by saying add testng library, I make it a testng test. Okay, I'm gonna import testng. Okay, perfect. So over here in my public void test, let's again keep it simple. Let's say system.out.println, and here let's say hi. This is Vardhan from Edureka. And after this, let me go to some web browser and perform some tests. Now, if I want to perform some operation, then I have to first of all set my browser driver. Correct. So let me do that. Let me say system.setProperty. Yes, it's right here, system.setProperty. And I'm going to say, what is it? Which is the browser driver I'm going to use? So it's going to be webdriver.chrome.driver. Correct. So this we need to, of course, give it inside double quotes. And where is my Chrome driver present? The path I have to specify. So my Chrome driver is present in my downloads folder. Okay, so I'm going to say, so this is my documents. I'm going to go to downloads. I'm going to copy this and I'm going to paste it over here. Okay, just that you have to note to give 2 slashes everywhere. So users, downloads, and Chrome driver.exe, because this is the name of my browser driver. Okay, now after this, the next thing that we have to do is I have to invoke an object for my browser driver, right? So let's say WebDriver driver is equal to, I have the assert function for that, right? So I can use assert dot, and once I've added the Selenium and the testng dependencies, then I would not have this problem anymore. Okay, so all these packages will get downloaded. So without wasting much time, let me go back to the pom.xml file, and over here, let me say what is it that I want to actually test. But before I say what I want to test, I have to first of all set my Maven plugins, right? So I have to add those details inside the configuration tab. I have said there's suit XML file. So this suit XML file specified in configuration is nothing but the actual testng.xml file which you are trying to execute. Okay, so let me not complicate this further and simply just copy this and paste it in my pom.xml file. Okay, this is my pom.xml file, and here I'm going to paste this build part. Okay, whatever is there inside my build tag. Now, beside this, like I told you earlier, we need the dependencies, right? So the 2 dependencies for Selenium and testng need to be copied, and this is the code. So for testng, this is the dependency that you specify in Maven, and for Selenium, this is the dependency that we specify. Okay, so I'm going to copy this, and again I'm going to paste it over here. Okay, but one thing you have to remember is, since these are 2 separate dependency tags, I have to specify them inside a tag called dependencies. Okay, so let me close this dependency tag over here. Brilliant. Now Control S, which would save it. So when you press Control and S, then that would be built over here and the dependencies would be downloaded for you. Okay, so now that the dependencies are downloaded, has been displayed. Hi, this is Vardhan from Edureka. Okay, perfect. Now I've always been telling you that in your pom.xml file, we specify the testng XML file which has to be executed. Correct? So to convert this Java class into a testng.xml file, you simply go here, click on this Java file and say testng. So over here, you can say convert to testng. So when you do that, it automatically converts to a testng.xml file. Okay, that's the default name. Let it be. Click on next and click on finish. Okay. So now you can see there's a new file here created called the testng.xml file. So if you double click on this testng.xml file, it basically is executing this Java program, Edureka demo Java program inside this Maven Selenium testng Jenkins folder. Correct? If you open it, this is the package where it's present, and this is the class. So that's what an XML file does. It simply and easily it says which class or which class to execute and in which package that class is present. Correct? So that's why testng.xml is such a brilliant file. So now that my pom.xml file and my testng.xml files are ready, I can straight away execute them and check if my test is running or not running. Okay. Now, before I straight away go to my Jenkins and start showing you how to build them, let me open up and execute this Maven project and see if my pom.xml file is working. Okay. I've just built it here. So let me open up the terminal first. And over here, I need to go to this project structure and execute this pom.xml file, right? So currently this pom.xml file, where is it present? Go to properties, it's present over here, correct? So let's first travel to this particular path. Okay. So here we have the pom.xml file, correct? So inside the Maven project, let's first run the command mvn clean. So this is just to make sure that any of your previous errors or bugs are just being cleared off. Okay. So mvn clean is good practice to run this command. So it says that the build is success, then so it successfully cleaned up the project. So now what we should do is we should run the command mvn install. Okay, so this will install whatever your pom.xml file says and whatever other things that are needed. So it's downloading the plugins, my compiler and the Shortfire plugin and all the others. Okay, perfect. Even my test is being executed now. So this is Mercury Tours. So what does it say? Okay, build is a success. So total tests that were run were 1 and there were 0 failures. Okay, perfect. Even my println command is executed. So now that my install worked, so let's just give the command mvn test. Okay. So by running the mvn test command, I am basically executing the test. Okay, I'm executing this program as a test. And this means that my Maven's pom.xml file is perfectly working fine for me. And the next thing that I have to do to conclude this demo is to execute this pom.xml file through Jenkins, right? So that's what I got to do. And to do that, let me first of all start off by going to the Jenkins dashboard. Okay, so Jenkins is hosted on port number 8080. So if you go here, you will find Jenkins. And to first of all execute the pom.xml file, we have to create a new job. Okay, so I can create a new job from over here, new item. But before that, for those of you who are using Jenkins for the first time, remember that you have to download the Maven plugin for Jenkins, and you can download that from Manage Jenkins. Okay, so if you come down, you have something called as global tool configuration, right? So go here and search for your Maven plugins. So you will have your Maven plugin here, and you will have to just specify the path where your Maven is present, your Maven home. Okay, you have to specify that over here. And once you're done with that, you have to just make sure that even your JDK is also mentioned. The Java home of your JDK, this is also mentioned. So when these two are mentioned, you can straight away start creating your job and start executing that job. So let's get to that then. Let's click on new item for creating a new Jenkins job. And this is going to be a Maven project, right? So this time I'll choose Maven project, and the name is going to be Maven Jenkins. Let's put Selenium and test ng there in the mix. Okay, so that's going to be the name of my job. And let me click on OK. So over here we have the general tools, we have the description under that, so all these can be avoided. So let's first of all straight go to the build part. Okay, so under build we have to specify which is the pom.xml file that we have to execute. So this is where you specify the path. Okay, if you remember, my pom.xml file which I have to execute, it was present under this path, right? So let me just copy that path under this path. So I'm going to copy this completely. I'm going to say OK, go back to my Jenkins dashboard, and I'm going to feed it over here. Okay, and here in goals and options, you have to specify the commands which you want to execute. So I showed you through the command prompt that I executed two important commands, clean and install. So that is the same thing that I need to specify over here. So before I install it, I want to clean it. I want to clean it with whatever previous history of the project was there. I want to eliminate that, and I'm installing a new one. So the second command that it would do is install. Okay, so that's what goal and option does for you. You specify what commands to run. And once I'm done with this, I'm pretty good. Okay, I can let me just minimize this for a minute. I can just say apply, and I can save this and straight away execute this particular job, Maven Selenium Test Entry Jenkins. Okay, so the option to do that is present right here, build now. So if you click on build now, the build will get scheduled, and let's see if the test case passes or fails. And we can also view what's happening by going to the console output. Okay, so this is the console output, and here, so this is the status. It's building the Edreka demo, the snapshot. So it's very similar to what you were seeing in the command prompt, right? So whatever gets displayed there, that since it's executed through Jenkins, it's displayed here on Jenkins. Okay, so even the system.println command is displayed, and now the Chrome browser driver should open up and go to new tools and perform the assertion. Okay, perfect, it's done. Tests run 1 and 0 failures. Okay, perfect.
Yeah, so that's it. So it was shown how Selenium is integrated with Jenkins. So when you pass on your build, then you run this Selenium file which he has created, and then your tests also will be run in Selenium, and you just go on modifying Selenium test cases as your application gets developed, and that continuous testing is implemented. Okay, so that's it for today. So Dr. Somnath, you want to say something? So
Audience, any question from your side? Any question that you would like to ask to Prakash sir, being as an expert in IT industry? Okay, well, no issue, sir. Thank you. Just only one kind request from our side to you, sir. Tomorrow, second session, we are going to have a valedictory. So please take out some time from your busy schedule and be there.
Sure, yeah. I'll be there. It's at 5 p.m., right?
Yeah, 5 p.m. Yeah. But 5 to 5:30 or max 5 to 6, there will be some interactions by Ranade sir. Ranade sir is going to interact. Ashok Ranade sir.
Okay, sure. I'll join that.
So around 6, we will start actual valedictory ceremony, sir.
Okay, great. Yeah.
Okay. Thank you, sir. Thank you on behalf of SVERI family, sir. It's really a great that you have accepted our invitations and having this interactive, informative session. Thank you for sharing your experience into our knowledge, and in future also we are looking to get connected with you, sir. Thank you. Thank you very much, sir.
Certainly, my pleasure. Yeah. Thank you, everyone.
Yes, sir. Thank you all. Next session we will start exactly at 5. Session may be little bit extended because there we have very good what we can say content today regarding that hackathons. So those the present you are in your college, how we can go ahead with international hackathon levels. This kind of interactions we are going to have. So don't miss the session. We will meet exactly at 5. Any doubt, any query, you can post on our WhatsApp group, or you can directly write a mail to us, no problem. So let's meet exactly at 5 p.m. Thank you all.